by experiment I meant designed experiment. Of course.
No.
No. Morally not possible. There may be certain things that we want to study, but we cannot give that to a human being. Morally is not always possible. There are moral implications, and we cannot study in a design experiment whatever we want. Okay, moving on to page 4. This is the next section, simple random sampling, what it means and how we determine a simple random sample. This is an important section, like the other ones, but this is even more important. Which page am I on? I think I'm on 4. So 1.3, we call it SRS, simple random sample, but the title is simple random sampling. Simple random sampling. So this is a process of collecting a sample. Process of collecting, what I like to say, a representative sample, a representative sample of the population to be studied. In which all my phones are ringing, but it's a colleague of mine, so he can wait. So to be studied in which any sample has the same chances of being selected. Any sample has the same chances, there's a C here. CHANCEES. No, that's not possible. I'm in class. Can I call you back? Did you finish your class? I have the Zoom link for the TFO meeting today. I can email you the Zinc. So, but also it's in calendar. It's in calendar at the bottom. Okay, the meeting is at 3:30 this afternoon. I will send it. Yes, I will email it to you. Yes, to your cloud, to your iCloud. Yes, I will. Thank you. Bye. There was a meeting at 3:30. My apologies. Sorry about that. That's why I keep it on for students, but I didn't think that he had an emergency. So it's one of my colleagues from physics. Okay, so any sample has the same chances of being selected. So let's just do a simulation right now. Obtain a simple random sample, SRS, of size n from a population of size uppercase n. We know that. The population has size n, and the sample size n, lowercase n, and it's coming from the big population. It's a subset of the population. Let's say we have a population of 435 individuals, and we want to select 5 of them. And we're going to use a TI-84, and we have 3 steps to go through. First step, we take the 435 people and we give them a number. So the first individual, let's say named Mani Khalid, gets number 1. The next, let's see, Hannah. Hannah gets number 2. let's say Jasmine is number 3, and so on and so forth, till the last one gets 435. Step number 2, this is step number 1. We'll label our individuals. Label individuals. Give them numbers, letters, whatever you want. So I know that each and every individual is identified by a number in this case. In step 2, I take my calculator. So if you have one, please reach out to it. And we're going to give me any number, please. That's our step 2. Give me any number.
41.
Which one?
41.
41. We want to use, we selected 41 as the seed to randomize numbers. Good, so we selected 41, and we're going to do this. We're going to enter 41. We're going to use this key, STO, second from the bottom, STO. It's going to store, wait for it, click on math now, go to probabilities. You can go this way or you can go this way, so I'm going to go backwards. Probabilities, click on select number 1, which already is selected, so press enter, and enter again. What did this do to the calculator? We are telling the calculator, listen calculator, I want you to randomize my numbers that I'm going to ask you to randomize based on seed number 41. You could say, but this is not really random. It's not. I agree. Nothing is really 100% random. So I gave it a randomizing seed to the calculator. Do you have to? No. But if you repeat the experiment several times, it's good to do it. Because otherwise you will always use the same seed and the same randomized basis, if you want. The seed is the basis for randomizing. So if you repeat the experiment, you should always come up with a different seed. You may say, how did you pick 41? Well, one of my students gave it to me. But at the same time, you can say, pick the seed from an urn. So that it's not somebody giving you the seed, but it's even the seed is randomized. Put those numbers in an urn and then pick one and say, that's my seed. It's pretty much the same, but that's step number 2. We haven't finished step number 2. So now let's go back to math. Again, back to probabilities, either way, wrapping or directly. And this time, we want to select number 8. So one thing that I want to mention before we do that is that we can randomize, or we can use a simple random sample, without replacement. I'll explain what that means. Or with.
I have a TI-83 and it only has 7 options.
Then you're going to use...
What's the 8th option supposed to be?
With no repetition, no replacement. No replacement or no repetition. So, I'll come back to this in a second. I need to explain this for one more minute. So, without replacement or without repetition, it means that if I select Emma in the sample and Megan in the first sample, they cannot be selected again. Done. If they were selected, I'm not putting them back into the population. I selected them, I took them out of the population. It's without replacement. With replacement, I select Emma and Megan, but I put them back when I select again the next group of 5 if I want to. So that is with replacement. So let's suppose we are interested in selecting or creating a simple random sample of 5 from 435 without repetition. Once I take a sample of 5, they're done. I don't put them back in the pot to select them again potentially. So we'll select number 8. Oh no. It's not a student. Okay, so going back to math and then probabilities and then number 8, we have to label them. So the lower, put the lower as number 1. The higher, the upper number as 435. And we want a sample of 5. And then click on paste. This calculator is slightly more sophisticated than others because it's a newer calculator. What I have, the calculator that I like the most is TI-86, but it's a probably 20-year-old calculator, and they don't manufacture them anymore. And this is the one I like, but it doesn't have the features that this one has. So when I press enter, I get the 5 numbers selected by the calculator randomly between 1 and 435 using a seed of 41. Now if you say I don't want to use the seed of 41, I want to use a seed of 56, fine, we go back and store that into, again, random number. Now we're going to use the seed of 56, and we can go back. Let's say this time we want with replacement, which means just random integers. Maybe you can use just that, random integers, but the random integers situation, it may give you repeats. If it does give you repeats, so lower is 1, 435, and n is 5, so we want to paste and just click in. And if it does give you 2 numbers that are the same, just repeat. Repeat the process one more time till you get 5 numbers that are not the same. And then you will always get without replacement. So if you don't have that feature, it's not a big deal. So just go back and use the random number that you have, the random integers. And if it gives you a repeat, then just simply annul that and do it again. If it gives you a repeat, annul that and do it again. And at some point in time you will. It's not common that in a sequence you're going to have a lot of repeats. So if you don't have that feature. Okay, and step number 3. So we label individuals, we perform the randomization process, and step 3, we just pick them from the population. So I go to the numbers. I didn't copy any, so let me copy just any list. So 327, 405, 270, 121, and 198. I just copied the last one. So then I go to number 327 in my list and say you are selected. I go to number 405 in my list, you are selected. I go to 270, you are selected, and this is how I create my sample of 5 individuals from this population. And I can repeat as many times as I want. So these are the numbers that I picked from 435. So, in this way, any sample of n small case n, 5 individuals can be selected, can be equally, or can have equal chances. Equal chances. Has equal chances of being selected. I didn't pick based on bias. I'm biased Let's say I want all people who are selected to have brown color eyes. I didn't pick, there is no bias. I just gave them numbers and I selected based on, so that avoids a lot of human error. And the simple random sample is a good sample representative of the population that we are studying. Here the population we are studying has 435 individuals. And this sample is a good representative sample of, it was randomly selected, has equal chances of being selected. Any 5 from here have equal chances of being selected in the sample. Any questions? Any questions?
Professor, I have a question.
Please.
Do you want us to take note of the notation in which the integer is inputted into the calculator? Like parentheses 1, comma, 435, comma 5? Or on exams, are we
Oh, it's a very good question. If you are using the calculator, that's the syntax of the calculator. Very good question. Thank you for asking. So that is the syntax of the calculator. You have to. So if you have an older version of the calculator, it's still fine. Don't throw it away or anything. But the syntax for these commands have to be followed to the T, otherwise you will not get the correct answer. So for example, it's like 2 parentheses 8 plus 2, right? So if I omit the, so what I want the calculator to do is 8 plus 2 first and then multiply by 2. So 10 times 2 is 20, but if I omit parentheses and just write this, and I did not use the correct syntax, I'm not going to get 20. Because the calculator doesn't know what I want. Or it may not even calculate in this case. So if I don't put parentheses, you may not even get the answer. But I think it should pop up with the left one anyway. If you don't put the last one, I think it's going to be okay. But this particular command will, I think, will pop up already with the left one. Is that what you had in mind?
Yes, but I also was wondering if on exams we were required to actually physically write that out, or if, since everything's electronic this semester, if all we were required to do is find the answer and put it.
Very good question. Very good question. So when you turn in your work, very good question. Thank you for asking that. So for the written work, so let's say one of the problems is asking me to determine 5 numbers out of 435, right? So I will say numbers are, and I'll put them with a comma. I don't have to copy the syntax from the calculator. Just put the numbers in. I don't need you to copy the way you determine them. Is that an answer that you...
Yes, thank you.
Thank you. Okay. Moving on. In addition to the simple random sampling, or the simple random sample, SRS, we have other options.